Just the background of the whole reason we're building P3, the reason we're building P3 is because we're moving out of ambulatory surgery from downtown to up here. And in doing that, we're keeping in contact with the codes and current standards of the state of Maryland. So it costs us less money to have people here and do the ambulatory surgeries outpatient. So the need for it was there. So on our campus, we currently have Green Springs Pavilion 1, Pavilion 2, our Falls and Joppa concourses. Now we have the addition of P3. Of all the backfill projects we're going to do, we're removing those elements from these areas and bringing them here and combining the actual practices. Very beneficial to us, and it's very beneficial to mix these practices. Like our big program we're pushing right now, which is musculoskeletal, we're combining the ortho and the rehab together. So you come to the practice, you don't need to go to another practice to see a rehab. You can go to the ortho the same day, go get your x-rays the same day, and go get your rehab the same day, all in the same place. So this is for our patients. This is for the future push for our entire system, and it's something that we would like to have be kind of like the poster for how ambulatory surgery centers are supposed to be. So in this situation here, with this building, it's very unique. We are in to a certain area here where it's something called jockey fill marble. So we had a lot of rock in the foundations here. We're built on same levels exactly, so you will pull in and you will be on level on both levels. So this parking lot is second floor, the first parking lot is first floor. You're going to come in, you're not going to really go up any downstairs, you're going to walk right into the lobby, and you go right to the elevator. The third floor for this building is actually dedicated to ambulatory surgery. So that is where we have 6 bays. That's urology, that's minor procedure surgery, so outpatient surgery, so nothing that stay overnight for.
And it'll be like one of the biggest day surgery centers in the state of Maryland with 6 surgery rooms.
Yep, the biggest one, that's important. So as we get towards construction, we did our planning phase. That took about 2 years. I worked with the previous director on this. We worked on design with the architects and engineers. This was a big deal coming in here. Green Springs Station here especially is related to an area where we have to upgrade the entire sewer structure all around here. So all the sanitary sewer downstream from this area we have to upgrade here on the site, and so other things like this. So this impacts not only just this area, but the community and the infrastructure the community currently uses. So there's a lot happening here with this project. Everything we do, we impact everybody else. So it was an endeavor to get to this point. Hey, Mike. So I'm going to hand it over to Mark, who's actually coming in from Muller Construction, who's the CA advisor, I believe, on this contract. So he is our construction advisor underneath us. We are the owners, and he represent us and run the GCs on this job site. So he's got more in-depth detail. So us and run the GCs on this job site. So he's got more in-depth detail. So we'll leave it to you.
To piggyback on what Wes was talking about, the project is about 120,000 square feet. It is a structural steel building with light gauge exterior framing and brick skin. The site had an existing tennis barn on it. There was a 3-acre tennis barn here that we had to download before we started the work. And in doing that, we encountered tennis barn. There were 14 indoor tennis courts. So first thing we did, came out, got our permits necessary to demo the building. We got released once we demoed the building, and then we started pad site for the building. Because it was a tennis barn, the area, as Wes had mentioned, there's a lot of rock. There's a lot of groundwater here also. So all of the site, we had to amend the soil. We use a process called soil cement, where you take the existing ground and mix into the ground Portland cement to stabilize the ground. And once we did that, we were able to put in a few of the site utilities and start the building construction. The building construction had a high PSF, pounds per square foot bearing ratio for the footings of 5,000. In order to achieve that, basically we needed to dig down to either bedrock and work back up. In doing that, we spent about 3 months trying to get out of the ground. We essentially lost 3 months on schedule bringing this thing out of the ground. Wes was talking about the rock. Hopkins did not allow us to blast the rock from the beginning, but we got approval to blast, and we had to actually use explosives in the elevator pit to get the rock out. We started the steel structure about a month ago. We made lower level pours, so all the lower level, which you cannot see from here, is poured out, so the deck is in, there's a slab on grade. The only areas that are not are a few of the MRI rooms. Hopkins buys their equipment at the end of the year to make sure they get the latest and greatest, so they're unable to pour that slab until we get that information. We made a slab on deck pour yesterday, which is the second floor elevation here, starting in 11 line back to 7.5 line. And the steel construction continues. We have guys out there today actually detailing. We can't run the crane because of the wet weather. The equipment we were talking about earlier. When the subcontractors come on site, we do a safety orientation. So it's my responsibility to check with that crane, for instance, that it has all the up-to-date inspections. They do an annual inspection, they do a monthly inspection, and then the crane operator does a daily inspection. He keeps that log in the crane to make sure if anyone comes, they can verify that. The load, that crane happens to be an 85-ton crawler crane. The swing radius has been figured out early on. For an OSHA standard, we are not allowed to be working underneath the swing radius of the crane as it swings steel. So we have a site-specific erection plan, and that's all reviewed early on. So before the crane even starts swinging any steel, everyone on site is aware of what's going on and where they can and cannot be.
It's marked off. It's marked off the radius of the crane.
No, it's an understood radius. You guys just stay out of that area. If it's a lot of people, which we don't currently have too many people here, we would coordinate that and get that area marked off. The cold weather that we've had has slowed us down also. So as you see out there, if you look, there's some plastic going up. On the lower level, we have plastic all around. For our concrete pour, we need to maintain temperature, certain temperatures, in order for the concrete not to freeze. So we made the pour on the second floor. Next week, our plan is to pour the third floor and follow it across as the steel erection goes up. Yes.
Are we able to know the temperature range, or is that confidential? Or
I'm sorry, what?
the temperature range that you were saying that the concrete had to be, are we able to know the temperature range, or is that confidential?
No, it's not confidential. So you cannot let concrete freeze. ACI, American Concrete Institute, has the cold weather standards kicks in once there's a average temperature of below 40 degrees. So once we have 3 days below 40 degrees, which around here is actually kind of hard to achieve, you do not need to work to the cold weather standard. But we did get below 40 degrees last week. So we had to implement all the cold weather practices, which would be concrete coming from the plant with accelerators in it, as approved by the structural engineer, hot water in all the concrete, and maintaining certain temperatures on the project. As Wes indicated, the project is broken up into 3 floors. There's different centers throughout the floors. For construction purposes, we'll attack the project from floor to floor, not necessarily suite to suite. We will begin.
Can you explain that? Floor to floor and suite to suite.
So there's multiple suites in the building. If we were to have separate building permits for all those suites, we could attack each suite and turn suites over. But here there's one building permit. So we're treating the building as just one big project. So sequence of construction, we'll go lower level first floor, we'll start all our interior and exterior framing, then work second floor, third floor.
So
Go ahead.
sorry, you made mention of ambulatory surgery. What type of surgery is that? Is it outpatient surgery?
The ambulatory surgery is on the third floor.
He said it is outpatient, it's just
Yeah.
for like day surgeries, there's no one that stays overnight, there's no patients that stay in the building, you know.
Minor procedures, endoscopy, urology, nothing major here, so you'll be able to walk out and go home after you've done your post, so, yeah.
So how many months are you supposed to,
So-
the duration of this project, and any problems you have encountered, how you able to keep
We-
the schedule?
Hopkins would obviously likes the project as soon as possible. Originally, before we
ASAP, that's the
Yeah, it
schedule.
should be done soon.
before we encounter our delays, we were projected to finish this the end of this year, December. We have lost 3 months, as I indicated. We are sitting with our schedulers and all the subcontractors, trying to figure out ways to fast track this and get it, back on track. I don't know that we'll gain the full 3 months, but we'll do everything we can to do that.
And in addition to that, even when, Mark can complete the construction, there's a period of time which they label activation, and what that means is, obviously it's not ready to move in because none of the equipment has been brought in, any new equipment, any furniture, so there's a period of time then when the building then gets upfit before it's actually ready to receive tenants. So that's, kind of like a follow-on, and it'll start to overlap with Mark's construction as he can turn floors over and they've been final cleaned, then the furniture and equipment can start to go in to prepare for anybody to move in. So there's a kind of that overlap period.
And the punch outs for the work, and get the walls to be removable for the MRI inserts. So this equipment needs to come in. So large segments of this building will not be complete. However, we still need to test up. We need to fit up the building as it's going. So the core structure, the backbone is IT, data, communication. So as soon as that's up and running, we can start having our equipment start to show up. The walls will be removed, of course. They're knockout walls, as they're called. So you knock out the wall, you bring the MRI equipment in and place it. Because you have certain heights, distances, you can't put your sprinklers in, and you can't do anything like that. You're gonna knock it and hit it. So you have to make sure everything is set up, and you have to plan and prepare for every single element that's coming in. And we have whole wings of X-ray equipment, MRIs, and CTs. So this building's got a
Those all
variety.
require obviously a larger area to get large equipment, medical devices into the building that won't fit through standard doors and et cetera. So a lot of the larger devices are actually going to be on the lower level that don't have to go up an elevator, a freight elevator, things like that.
Hey Terry, got a question here.
Yes.
So the parts, like basically you're saying the equipment will be brought in first, for like the medical equipment and stuff will be brought in first before you guys do any like utility or electrical stuff like throughout the building?
It'll kind of be, it's kind of working together. I mean, the construction will continue, where there will be a period of time when, we have to have it prepped to a certain stage to allow the equipment, the big pieces to come in, and then those items typically have to be, connected, to the power sources, et cetera. So that's kind of a piece that's kind of going on, coordinated with whatever's happening with the construction piece.
And commissioned too.
So what happens with that is, required by our building permit, which I have all the permits for the different trades in the building permit on the wall in the back left corner there. It is the general contractor's or CM's responsibility at this time, before the owner could come in and do anything, we would either have to get a final building occupancy permit or a stocking permit. In this case, we'll get stocking permits as early as possible so the owner can come in. What that means is we would have had most likely final electrical inspections done by the county and signed off. That would allow the owner to start coming in and doing their work.
It does take a decent amount of time to allow all the equipment, whether it's large or small, to, be brought into the building and connected or set up before, you're ready to actually use the spaces, so.
Yeah, Iman,
Yes.
why you are in electrical? Industrial?
No, I'm actually industrial.
Industrial.
And I low-key had a question about, because I recently just took a class on where we had to learn crashing and everything, where like you have a certain time frame for your project, and then we had to be able to calculate like certain projects that were like, oh gosh, I'm forgetting the name right now, but it's basically like, the critical path, where like you have to be able to like, it's certain things that can't be moved, like they have to be done in their time frame, and then there's other stuff that have like maybe a 3-day gap period, or like that was just our example of days, but it might be like 3-month where we had to like calculate that. So like, did you all have to like do that actual process as far as like crashing and seeing how many days like you had to like give on certain projects?
We create a project schedule. It's all based on critical path activities. And then the other, activities that go in between have the float that you were talking about. So as long as we hit the milestone critical path activities, we can work the other activities in as necessary.
And
So
It's a pretty meaty schedule. I mean, if you have a sample of that, I think that would be interesting for them to see. It's pretty meaty.
And regarding with the crash scheduling, in this situation, we had enough forethought to, we could, if we needed to, we dictated the schedule and times. So we told everybody how we're gonna be meeting these schedule and time periods. So if we're setting this up for crash schedule, it's a little bit different. Say if you're coming from a performance standard, or you're the engineer and I'm the owner and I said, I need this done in 6 weeks, and you're 3 weeks out, that's when that's really important to have that crash schedule, get in there, condense the entire schedule frame and look at your critical path, and really get your swim lanes established and start the project. And then that's a very interesting thing that you did in that project. That's pretty good. And crash schedules are very difficult. We just did a recent project. What do you think? Neurofusion was going to be a 2-month project and 3-month project at least. We did it in 6 weeks. I mean, that would have been the perfect example of that. I mean, that was fast. I mean, that's high-end products. I mean, we delivered the project and we still had long lead items delivered. So we were still closing this project out, but we were told we needed to get it done within that time frame. So we managed to get the job done.
Interested in construction management. There are various methods of scheduling, as it has been said. There is the one that you just use the pie chart and just see what you do from month to month. But the critical path method that they are mentioning is about to be able to look at the sequence of the activities. Take for example, if you want to start a construction, the first thing you excavate the foundation. The surveyors will come, do the setting out, if that's first activity. After we, excuse me, they will excavate for the foundation, then they will pour the concrete and do the foundation. If it's steel, they will put it down. So all these things are in sequential order. So the activities are in sequential order. So you have to plan it ahead of time. It's a very great job because you have to make sure that the workers are around at the time that activity is supposed to be done. The equipment are there, the materials are there. Everything is not when they are starting to pour concrete, then you forgot that there is no cement there. So everything was already been stored well ahead.
Right.
And then what Iman and what they are talking about in critical path method, you look at the sequence of activities that are very, very important. And then if you want to shorten the time, what's your name, sir?
West.
Like Mr. West said, if you want to shorten the time, how can you think you can shorten the time of construction? Like we told them, like he said, they were giving the 3 months, do it within 3 weeks. How can you do it?
I mean, you could combine activities, certain activities, like they said, the main thing would be talking to the actual workers, because I mean they're the people actually doing the work, so they would know what certain things would be able to be done faster, or what they could be able to. So like if us three are doing one assignment, and they will be able to know, like, okay, well, one person can actually do that and they can actually work on something else, so that can help shorten the duration of movement.
Iman, you are raising up your hand.
Oh, I was saying that, like, this is just, like, based off my class, where, like, we basically, like, were able to, map out all the time frames of, like, the start and finish time of it, like, how long, activity would take, and then, like, basically the ones that, like, didn't have, like, we would do from start to finish, and then based off the slack, we will also, like, calculate it backwards, if that makes sense, to see, like, yeah.
So sometimes, like the critical part, which is very important, are driving workers to that area, because everything is involved: material, equipment, and labor. That's all what is done in planning: material, equipment, and labor. So you plan that, okay, if you want it to be executed speedily, there are some that it gives time to, like concrete, to set. But you may use some additives, rapid hardening concrete, rapid hardening additives that you put those, but it's going to increase the cost. But you see, sometimes contractors are given incentives if they are able to finish their project on time, because the client wants it, like they said, John Hopkins said they want it ASP. Sometimes, so when they are bidding, before they got this contract, there were a lot of contractors that bidded for it. So there are a lot of technical interviews that I've gone through and all these things. So these are very important in engineering. You understand what
Yeah.
I'm saying? So you do all these things, but you must complete the project. There are 3 things in project management: on time, within budget, and according to specification. So that's the responsibility of the construction project manager to ensure that these 3 things are met. Complete the project on time, within the budget, because the clients but it's only as very rare occasions there can be discrepancies in the budget. Then everybody must have to agree on it, and then within the specification.
So there's the scope of the work, the budget and the schedule, and understanding maybe the most important function, which one of those is most important to the client or the owner. That may change how you actually design the building. If you say its schedule is my driver, you might approach it another way. If you say, whatever. So sometimes understanding the goal of the owner and what their most important thing to them is at the beginning.
And with the delays, the 3 months we've been talking about, the project cost, we are going to go up. We haven't gotten a final tally on the numbers, but we'll be over $500,000 in change orders just getting out of the ground in order to get the building. So that's above and beyond what was figured by Hopkins. When that happens, the owner typically, especially coming out of the ground, because you don't know what you're going to encounter, the owner will carry a contingency for the project. Given the geological reports, knowing that the ground out here wasn't that good, the owner, I believe, did carry the proper contingency, so they are covered. But
right, it's just a pocket of money for those who don't understand the word contingency. That if you run into an unforeseen condition, you still have some monies that you can apply to it to solve the problem.
It's like a safety net.
It's exactly
Safety
right.
net.
So right now we're eating into our contingency. We need to make sure to manage that because we do have the other phases that are coming up. We talked later in phases about tenant fit outs and things like that. There could be major change orders that happen. We designed it to where we can get to a certain point. However, if a room needs to change, we need to tap into that money, into that account, and make the change. So if the tenant and the client says, well, this looked good on paper, but I don't like it, we have to redo this whole thing, we're back to eating into our contingency again. So if we manage this well on this end for the actual coming out of the ground phase, we actually have money later, our safety net, for other things that come up. This is a duration project, so throughout this duration of the project, the change orders are affecting how our contingency comes together. Because we can't go back and ask for more money. I mean, that's
You just have to use it wisely. When something comes up like that and you have that bucket of money, you have to make a decision, how comfortable are you using, what percent of it early on in a project versus having some, contingency left at the back end of the job.
paying out of other sources.
They have to decide, us as the owners would have to decide, do we want to reach out for more money in another way, or sometimes they're just someone who's moved in the building, the end user. It's just hey, I don't like what I told you before, now I want this, and the answer is no, because we don't have the funds to make that change for you.
And being in the hospital system, we have board driven. So everything's a community based, everything's board driven. So if you have to go to your president and he's got to go to a board in order to talk to the board members to convince them that we need more money, it's a very difficult thing to do. It's not like the change order comes from their end, we drive it, we vet it, we look at it, Terry and I will take a look at it with our president and our building team, and we go, okay, well, this is the issue, this is the situation, we need to have you go pitch and see if we can get more money, or this is not going to happen. If we have delays, the change orders can come through. We can actually do a change to the directive of the entirety of the job as well, to make sure that this works, to actually have backing that comes down to our way so we can get the money back on the job.
So-
That can cause delays.
So, the long and short of it is, we try to work within the project budget and whatever contingency we have, and said if it goes beyond that point, there's typically, a negotiation that has to go on at a higher level within the Johns Hopkins organization, say, to see if there's additional funding we can bring to the project. But we certainly try to manage what we have and stick to it and use the contingency for things that we don't see coming, not things that just someone wants to make a change, midstream.
And that is also impactful. If we borrow money from them, it borrows money from other projects that are on the front end. So we could have $1 billion projects happening, we have to eat into their contingency in order to feed our project. So forward planning really affects the entire job. I mean, it goes all the way up. So it's just something to keep in mind if you're running projects, you're on projects, that money is the bottom line. Keeping on budget is the bottom line. Keeping the client happy is also, a bottom line, so. But that's just the point, that's a good question, actually, so.
For those of you in civil engineering, all of you are all engineers. What engineers do is solve problems, okay? Some of you in civil engineering, you will take a class with me, soil mechanics. So that's talking about understanding the nature of the soil. So what they said was that sometimes when you have done the subsoil investigation, you may not know what is under the ground. There are a lot of uncertainties in the soil, but until when you now mobilize. So there were two things which they discovered. They said that they encountered some rocks, and because of blasting, because of noise, because this is very close hospital, so the client said they must not blast, use that methodology, or sometimes when you blast too much, it affects the surrounding foundation. So as an engineer, how do you solve that problem? You see, your client says you cannot blast, because when you start to blast, this is a very quiet area. So how do you solve that problem? Do you bring a silent equipment that can be used to blast? How do you solve the problem? So then you look for a cost-effective way of solving that problem within the confinement of whatever you need to do. So you have to be creative. Then another thing, that the soil there was not good, so they had to stabilize it, mix it with cement. That's soil stabilization, so that they can, you see, that's what they call the bearing capacity. Said it must be 5,000 psi. So that is it's like the bearing pressure. You see, the load from the building, then the pressure is like this. It's like you say that if Deborah, is that Deborah? Deborah cannot carry an empty man like this. She will collapse, or me tell you to, but he can easily carry me. You understand? That's exactly what the bearing pressure is. So the pressure from the soil to carry the coming load, it must be greater than the pressure, the load pressure coming down. So you must ensure all those things. So when they talk about contingencies, it is not certain. So in any project, you have that amount of money for some contingencies, unforeseen circumstances, what you cannot do. And money is very important. I usually teach engineering economics, and the time, that's why they move money around from one point to the other. It's very, very important. So once you have this, you do what we call change order, because it's different from what you have agreed upon. And before there is a limit for a change order that just the engineer can approve. It has to go through the board. So take for example, they said it has to cost $500,000. There is from the contingencies, I've seen all this. So as engineers, that's why we are teaching in school to know all these things and then come out to solve all the problems.
I have a question about the bearing that we were just discussing. So with that, because I'm trying to visually understand the structure of how the building is being built. So in my head, I'm thinking of because I know I've basically had to research on how to build a fence. And so I know with the fence, it's not just sticking a little bit in the ground. It's it has to be I think 3 feet or something of it in the ground. So then you have to have your rod a certain length or whatever. So it's actually secured and supported in the ground. So if something were to happen, it won't just pop right out.
Yeah.
So in my head, I'm is the building are we building a foundation? Okay, the ground has to be solid so that you can build a foundation for it. So then you can stick the structure inside it for it to be.
So what we have here is the 3 feet you were talking about typically is for frost. So
Okay.
you want your footing to go deeper than the frost line in a given area. So 42 inches around here is different than if you were working in upstate New York. The frost line might be 60 inches. So for fence posts as you were talking about, or a footing, you literally have to go 60 inches into the ground. So here, when we were trying to achieve our bearing capacity, there would be a DCP, a dynamic cone pentrometer, that they would take and try to test the ground. And once they take a certain number of blows to see if we have 5,000, we have to dig down to bedrock here in this instance. So when we dug down to bedrock, excuse me, we poured back up to the bottom of design footing as agreed to with everyone at the table financially and the structural engineer. We used lean concrete, which was 2,000 PSI concrete to come back up to the bottom of the design footing. And then we poured the design footing on top of that. So here, to the PSF and the structural engineer and the height of the structure and how much weight it's bearing, they come up with the footing design. So we put our footings in here, which most of the standard footings are 1 foot thick and 6 feet wide.
Okay.
And then off the top of that, there's rebar that comes out of it. And then we have poured concrete foundation walls here
Okay.
for the foundation level.
Okay.
To that point too, nothing goes correct and nothing's perfect. So out here, I mentioned earlier about voids. The geology of the site has waves. As we hit a certain area, we were digging down to a couple of these footers. We've dug through it, and now we have a cavernous void. Standard procedure would be that what he just described. For most part, we pour our footers. It's on bearing soil. We can continue to build that structure above it. In this case, we had how many trucks of concrete we had to fill in some of these voids? We brought in at least 30 cubic yards. I mean,
that's what added up to the tremendous project cost to bring this thing out of the ground. But in a footing distance, say the length of this table's 18 feet. We had some areas where we had to dig down up to 15 feet deep. So in an area about actually the size of this table, we poured up to 70 feet of concrete that was not necessary for the building structure, but necessary to achieve bearing. So just in an area this long, we spent $10,000 to $15,000.
So it's essentially like you had to create the stable foundation before you actually
Correct.
even went to the bearing portion.
so there's a risk that most jobs have. An assessment on the job, you can do your risk assessment, and you usually have a way of taking a picture or a photo of it. Hence the initial engineering look at the whole job. We bored, we looked at it. From that risk, we made an assessment and we said, okay, we can continue and do it a certain way. The thing we could never do, and every project is perfect, is now we found these voids. I mean,
There were holes in the ground where there was nothing there.
it's just,
so-
we have to backfill with trucks in order to, we also have water filling up at the same time. So the concrete actual structure in which you're pouring is not going to be the same. The liquid and the actual Portland is not going to be the same. So you have to be ahead of the actual hydrology filling that hole up. So there was a lot of work from Mark and his group to get us to be at where we need to have our footing points at. This is all throughout this project.
You can take test holes, but certainly you can't project every location. You're drawing assumptions from the test holes, the test pits that you're taking of what you can find in other areas, but that's not always the case, obviously, and then that's where you come up with the unforeseen condition.
And that's the snapshot I was talking earlier. You could take a small boring about this big and about 30 times, but you're only looking about this big. There's no way, unless we did some form of ground penetrating radar, to look at the whole site. So you do a guess, essentially. And the engineer has to be creative, what you mentioned before also. He needs to be able to say, all right, well, this is the condition across the site. Here's my best assessment. Here's my risk. Here's my...
Unfortunately, in this situation for Hopkins, it was an existing structure here. So the original borings that were done to create the foundation design were done outside the footprint of the existing building. The new building is within the footprint of what was the existing building. So when we came in after we took over that building and did more locations, we found that we encountered what we see here now, but it was too late to change the entire design. So due to project schedule, we moved forward with the initial design, and this is what we ended up with.
And we had to continue driving it because we do have our end date to keep in mind. So tying it all back to our earlier discussions, this is how this all comes together.